Hey everyone, ready for another deep dive? Today we're looking into some cutting-edge AI research, specifically a new model for conversational question answering.
It's called ChatQA,
ChatQA.
and it's really generating a lot of buzz.
Oh, why is that?
Well, for one, it's designed to outperform even GPT-4.
Wow, okay, so we're talking some serious AI advancements here.
We are.
So, I guess like most AI these days, it all starts with the training data, right?
Yeah, so the researchers actually outline their whole approach in their paper, ChatQA Surpassing GPT-4 on Conversational QA and RAG.
Okay, so we've got excerpts from the actual research paper.
Yeah.
And I have to say, it is pretty technical,
Mm.
but I think we can break it down.
Yeah, definitely. I mean, their goal was to create an open source model
That's
that
fantastic.
could not only hold a conversation, but actually pull evidence from different sources.
So like cite its sources.
Exactly. And even handle complex things like calculations.
Wow, that's really impressive.
It is.
So how did they train CheckUA to be so, I don't know, conversational?
Well, they used a two-stage process. Section 3.1 of the paper goes into detail on this.
Okay.
The first stage is supervised fine-tuning, or SFT for short.
Gotcha.
They basically fed ChatQR a massive amount of data.
Like how massive are we talking?
They used data from a variety of sources like SOTA, ELI5, MLAN, Open Assistant, and the Dolly datasets.
Okay.
Appendix A.1 of the paper actually lists all of these.
Wow, that's a lot of data. So it's like they enrolled CheckQI in some kind of conversational boot camp.
Yeah, I like that analogy. They exposed it to all sorts of different dialogue styles and scenarios.
And that was just stage one.
Right, so then stage 2 is what they call context-enhanced instruction tuning. And this is detailed in section 3.2. It focused on fine-tuning ChatQI's ability to answer questions within a specific context. So like, imagine a conversation where each question builds on the previous ones.
Right.
That's what they trained ChatQA to do.
Okay, so this sounds way beyond like those basic chatbots that you see popping up everywhere.
Oh yeah, definitely.
To train for this second stage, they used a combination of human annotated data and synthetic data. They refer to these as human annotated conv-QA and synthetic conv-QA, respectively.
Yeah, they talk about those in Appendix A, Pot 2.
So mixing the real with the simulated.
Right. And that's key because it helps ChatQA handle the complexities of real conversations. Real-world conversations.
Because real conversations are messy. At least mine are.
Haha, well, yeah. But anyway, for ChatQA to be accurate, especially in these multi-turn conversations that we've been talking about, it needs to be able to retrieve the right information.
Okay.
Section 4 of the paper talks about that.
Okay.
And traditionally, that often involves rewriting queries based on the history of the conversation.
Oh, I see.
So like, as the conversation gets longer and more complex,
It gets harder to keep track of what's relevant.
and it gets computationally expensive too.
Okay.
So with ChatQA, they did something different. Instead of rewriting the queries, they trained a single-turn query retriever. And this was trained on a data set of conversational questions and their contexts. You can actually see this in Figure 2 of the paper.
Okay. So this retriever, it understands the nuances of a conversational query without needing to go back and rewrite things.
Right, making it much more efficient.
Cool. So once they had ChatGPT all trained up, how do they actually test it?
Well, they developed this whole new benchmark called ChatRAG Bench, specifically to evaluate ChatQA. They describe this in Section 5.
Okay.
It's made up of 10 different data sets, and these cover a range of tasks and challenges.
Like what? Give me some examples.
Sure. So some of these data sets involve really long documents, like way longer than what typical language models can handle. So retrieval becomes essential.
Okay.
A couple of examples are the doc2dial, quasi-QRECC, TOPI-OTQA, and in-SCIT datasets. Table 1 lists them all.
So they really put those retrieval capabilities to the test.
Oh, yeah. But they also included datasets with shorter documents, things like CoQA, DoQA, ConfinQA, SecQA, and HybridDial. These can be processed directly by LLMs without retrieval.
Okay, so like a mix of long and short, complex and simple.
Right. So it's a very comprehensive testing ground.
So what were the results? Did ChatQA live up to all the hype?
It did. So the model based on the Llama 2 architecture, that's called ChatQA 1.070B.
Okay.
That one outperformed both GPT-4 and GPT-4 Turbo 2024-0409 on the ChatRAG Bench.
Wow.
Yeah, it's pretty impressive. And all of this without using any synthetic data generated by OpenAI models.
That's a big deal.
It is, especially for an open source model. All the results are in Table 2 of the paper.
That's great. Okay, so now we're getting into some of my favorite stuff. What about those situations where there just isn't an answer? Like when the AI tries to make something up instead of just admitting it doesn't know.
Yeah, that's the problem of AI hallucination. It's a big one. And it's something that the researchers really focused on with ChatQA. Section 6.5 of the paper talks about this.
Okay.
They specifically train ChatQA to recognize when a question can't be answered. Based on the information it's given, that is...
Right. So basically they taught it to say, I don't know.
Yes. Exactly.
Okay. But how did they do that? Like, did they just tell it to say, I don't know?
Well, not exactly. They incorporated both answerable and unanswerable scenarios during training. They used data from the ChatQA and ChatQA datasets for this.
Okay.
You can see this in Table 8.
Gotcha.
And what's interesting is that even a small amount of this unanswerable data significantly improved ChatQA's ability to, well, to not make stuff up.
So it's not just about giving the AI all the answers, but also teaching it to recognize the limits of its knowledge.
Right. To know what it doesn't know.
I like that. Very philosophical.
Yeah, a bit. So to evaluate this whole, I don't know, aspect, they used both automatic metrics and human evaluations.
Okay.
Section 5.3 goes into this.
Right.
And they compared ChatQA with GPT-4 on this.
Oh, cool. So they actually had people judge whether the models were really understanding this whole concept of not knowing something.
Exactly. And while the automatic metrics showed that they were both pretty similar, the human evaluations gave a bit more nuance. They showed that ChatQA was sometimes more accurate, especially when it came to things like calculations.
Oh, interesting. So it sounds like it might be particularly good at those tasks that require precise numerical understanding.
It seems that way. You can see the results from the human evaluations in Table 4 of the paper.
Okay, so different models, different strengths. It's fascinating how that works.
It is.
So did the researchers actually compare ChatQA and GPT-4 in any, like, real-world scenarios? I mean, outside of those benchmark tests.
They did. They have several case studies outlined in Section 7.2 of the paper. You can also find them in Table 10 and Appendix G. It's like watching a competition between two AI heavyweights.
Ooh, I like that. So I imagine these case studies reveal some interesting things about how these models approach different types of problems.
Yeah, definitely.
Like what? Can you give us an example?
Sure. So in one case, ChatQA nailed a question about nature reserves.
Oh, man.
But GPT-4 stumbled a bit. And then in another case, one that involved dates and historical events, GPT-4 demonstrated a real knack for detail that ChatQA just didn't have.
So it's not just about which model is better overall. It's about choosing the right tool for the specific job.
Exactly. The right AI for the right task.
Makes sense. Okay, so back to ChatQA's training for a second. Remember those two stages we talked about? Well, in Appendix A, they go into a lot of detail about the data they used and how it was formatted.
Yeah.
So each example includes a system role, followed by user and assistant turns, like a back-and-forth conversation.
Right, and this basically teaches ChatQA how to follow instructions and stay coherent in a conversation.
Just like we're doing right now.
Exactly, but in written form, of course.
Of course. So in that second stage, the context-enhanced instruction tuning, they added a section for, what was it, context for latest question, right?
Yeah.
So that gives ChatQA all the background information it needs to answer those follow-up questions.
Yep. And they even tailored the instructions based on the type of answer they wanted. So like a short factual answer versus a detailed explanation.
Well, that makes sense. You wouldn't want to ask for a one-word answer when you're expecting a whole story.
Exactly. And then in Appendix B, they talk about how they experimented with using synthetic data to augment their training data sets.
Oh, right. The data generated by GPT 3.5 Turbo.
Yep. And they use this two-step prompting technique to generate multi-turn conversations.
So GPT 3.5 Turbo was essentially creating practice conversations for ChatQA to learn from.
That's it. And they actually went a step further and refined those conversations by adding pronouns and common nouns just to make the dialogue sound more natural.
That's pretty clever. Okay, so I want to circle back to the retrieval aspect a bit. They went with a single-turn query retriever, right?
As described in Section 4.1.
Instead of those more traditional query rewriting techniques.
Right. And their findings, which they outlined in Table 1 and Appendix C.2, showed that this actually produced comparable results to using GPT 3.5 Turbo for query rewriting.
Wow, okay. So it's a more efficient way to get the same outcome.
Plus, it significantly reduced the computational overhead and, potentially, the API costs. They discuss that in Appendix C.1.
So it's a win-win.
Pretty much. So to train this retriever, they actually created a whole new data set. They combined the human-annotated conv-QA and synthetic conv-QA datasets.
Okay.
And To make sure this data set accurately reflected, the nuances of conversational question answering, they selected the most relevant chunks from each document based on their 4-gram recall score with the agent's answer. Section 4.1 explains that process.
Okay, that's a lot of technical detail.
Yeah.
But it sounds like they really went all out to ensure the quality of their data and the accuracy of their evaluation methods.
Oh, absolutely. They were very thorough.
So back to that ChatRAG Bench we talked about earlier, the benchmark they used to evaluate ChatQA. Section 5.2 goes into a lot of detail on that, and all the data sets it includes.
Right. And we touched on those data sets earlier, but it's worth digging a little deeper into the specific challenges each one presents.
Okay, so for example, doc-to-dial. That one has an average document length of over 100,000 words.
101,000 to be exact.
Wow. Okay, so that really puts those retrieval capabilities to the test.
It does. Then you have data sets like ChatQA and QRECC. Both are based on Wikipedia, but they have different average document lengths.
Okay.
And for ChatQA, they actually extracted text from multiple Wikipedia links, which pushed the average document size up to about 15,000 words.
So ChatQA wasn't just finding the right information, it was also dealing with these massive amounts of text.
Exactly. And to make sure things were consistent across these data sets with their different document lengths and chunk sizes, they adjusted the number of retrieved chunks they used as context. So for example, with doc-to-dial, QAC, and QRECC, they used the top 5 relevant chunks. But for TOPIO-CQA and NSCT, which involve things like underspecified queries and topic switching, they use the top 20 chunks.
Oh, okay. So they were basically giving ChatQA different sized tools depending on the complexity of the task.
That's a great way to put it.
And then they included things like TOPIO-QA, which requires the AI to search the entire Wikipedia corpus for answers, and NSCIT, where the user questions are underspecified and need clarification from the AI.
Right. So it really threw everything they could think of at ChatQA.
So how did it do against all of that?
Well, ChatQA 1.070b, the one based on Llama 2, it actually aced it, even on data sets like doc-to-dial with those super long documents.
Wow, okay. So they created an AI that's basically self-sufficient. It can handle these really complex conversations, A&D information retrieval tasks, all with impressive accuracy.
Yeah, that's one of the big takeaways here.
That's pretty amazing. Okay, so I'm curious, did they just use a single metric to evaluate ChatQA's performance?
Well, they primarily used the F1 score. That's described in Section 5.3.
Okay.
It's a pretty common way to measure accuracy in question answering tasks.
Gotcha.
But for ConfinQA, they actually use the exact match metric, because in finance, precise numerical answers are really important.
Right. You don't want any rounding errors when it comes to money.
Exactly.
Okay, so besides these automatic metrics, they also did those human evaluations that we talked about before, right?
Yeah, to compare ChatQA with GPT-4, they had annotators judge how accurate each model's responses were.
And what did they find?
Well, they found that both models were often equally accurate. But ChatQA was a bit better at the tasks that involved calculations, as we discussed earlier. Table 4 shows those results.
So each model has its own strengths.
Fascinating. Okay, so I'm wondering, did the researchers look at how each part of ChatQA's training process contributed to its overall performance?
They did. They ran a bunch of what are called ablation studies. Those are detailed in Table 3.
Ablation studies. I'm not familiar with that term.
So essentially, they remove or modify specific components of the model or the training process and see how it affects performance.
Oh, okay. So it's like taking ingredients out of a recipe and seeing if the dish still turns out okay.
Exactly. And what are the key things they learned was that removing the first stage, the supervised fine-tuning, that led to a performance drop across pretty much all the data sets. Oh, wow. So that initial conversational boot camp is really important.
It is. And removing the second stage, the context-enhanced instruction tuning, also caused a big decline in accuracy. So context is key.
Makes sense. So both stages are crucial for ChatQA to really understand and answer complex questions.
Right. And they also looked at what happened when they used different types of data during training. Removing the single-turn QA datasets from the second stage generally led to lower scores.
Interesting. So even though those single-turn datasets might seem simpler, they still play an important role in training a model that can handle back-and-forth conversation.
Exactly. And then removing the conversational QA data had a bigger negative impact, especially on the data sets with text-based documents. So training on conversational data is really important for, well, conversational question answering.
Makes sense. To be a good conversationalist, you need to practice having conversations, not just answering isolated questions.
Right. And then they compared using human annotated data versus the synthetic data generated by GPT 3.5 Turbo. And they found that both approaches gave similar results. So using high-quality synthetic data could be a viable alternative to human annotation, at least in some cases.
Okay, so constantly pushing the boundaries, it seems.
Yep. And you can really see their meticulous approach in these ablation studies.
Okay, so let's move on to Table 5, which breaks down ChatQA's performance based on different dataset types. What can we learn from that?
So Table 5 shows that ChatQA 1.070b, the one based on Llama 2, it does better on the datasets with text-only documents compared to those that include tables.
Okay, so ChatQA seems to be better at understanding and reasoning with text.
It seems that way. But the Llama 3 ChatQA 1.5 models, especially the 7EB version, those were actually better on the datasets with tables. So the Llama 3 architecture might be better suited for tasks involving tabular data.
So ChatQA for text, Llama 3 for tables.
It seems so. And the table also shows that ChatQA 1.007-70b performs about the same as GPT-4 on both retrieval and non-retrieval datasets.
Okay.
So it seems its retrieval capabilities are on par with other state-of-the-art models.
That's great. So they've created a model that's good at conversation, and good at finding the right information.
Right.
All right, what about Table 6?
So that one looks at what happens when you incorporate retrieved chunks during training.
Okay.
They compared ChatQA 1.070b when it was trained with the top 5 retrieved chunks as context versus when the entire document was used as context.
So is it better to give the model the whole document or just the most relevant parts during training?
Well, as we've seen, using retrieved chunks during training helps performance on those datasets that require retrieval, but it actually hurts performance a bit on those that don't.
Interesting. So there's a trade-off there.
It seems so. The researchers point out that using retrieved chunks during training makes it more like the inference stage where retrieval is needed. But it can also make the training process less stable, which might explain the lower scores on the non-retrieval datasets.
Okay, so there's a balance to be struck there.
Definitely.
What about Table 7? What's that one about?
That table is about the ablation studies they did during the inference stage.
Okay, remind me, what are ablation studies again?
They're basically where you remove or change different parts of the model or process to see how it affects the results.
Gotcha. So what did they learn from those?
Well, one thing they found is that using more contexts doesn't always lead to better answers. Using the top 5 contexts generally gave the best performance.
Interesting. You'd think that more information would be better.
Yeah, you'd think so. But it seems like there's a sweet spot. Too few contexts might not give you enough information, but too many can overwhelm the model and make it hard to find what's really relevant.
So it's about finding the right balance.
Exactly.
What else did they look at?
Well, they also looked at how different context orderings affected the results. They compared sequential ordering, reverse ordering, swing ordering, and random ordering.
Wing ordering, what's that?
It's a way of arranging the context to try to avoid what they call the lost in the middle phenomenon, where information in the middle of a long context can get overlooked.
Oh, interesting.
And what they found was that sequential ordering, where the contexts are arranged from most to least relevant, that actually performed about the same as reverse and swing ordering. But randomly shuffling the contexts was a bit worse.
So as long as there's some logic to the order, ChatQA seems to do okay.
Right. And then they also compared using the fine-tuned retriever versus the original Dragon retriever.
Okay.
And they found that, as we saw earlier, the fine-tuned retriever gave better retrieval results, which in turn led to better question-answering performance.
So having a good retriever is important.
It is.
Okay, so let's go back to Table 8 for a second. That one was about how ChatQA handles those unanswerable questions, right?
Yes.
Can you remind me what they found there?
So that table highlights how important it is to have good training data for handling those unanswerable questions. They found that using human annotated data really improved ChatQA's performance in those cases. And ChatQA 1.070b actually did much better than GPT 3.5 Turbo, though it was still a bit behind GPT 4.0613. But importantly, they found that adding even a small number of unanswerable examples during training made a big difference.
So it's not just about teaching the model to find answers, but also teaching it when there isn't an answer to be found.
Right, and having a good data set with a good number of unanswerable examples can really help reduce those hallucinations.
Okay. What about table 9?
That one shows how ChatQA performs on single-turn question answering and retrieval augmented generation benchmarks, so beyond just the conversational stuff.
Okay.
And they tested the Llama 3 ChatQA 1.5 models on these.
How did they do?
Really well. Even the smaller 8B model outperformed the state-of-the-art RADIT model, and the 70B model actually surpassed all existing frontier RAG models on these benchmarks.
Wow, so they've created a model that's not just good at conversation, but also great at single-turn question answering and RAG tasks.
Exactly. And then finally, there are the case studies in Table 10 and Appendix G.
Right, those real-world examples comparing ChatQ 1.0-70B with GPT-4 0613.
Yep. Those really highlight the strengths and weaknesses of each model.
Can you give me a few specific examples?
Sure. So in one case, they had a question about VA appeals processes. Both ChatQA and GPT-4 managed to get the right answer from the text they were given.
Well,
But GPT-4's answer was more comprehensive. It included extra details about, like, the conditions for following the new process.
so GPT-4 was more thorough.
Yeah, I guess you could say that. And then there was another case where the question was about the age of a child that was mentioned in the text. GPT-4 correctly stated that the child's age wasn't actually provided,
Okay.
but ChatQA assumed the child was a baby, just based on the context.
So GPT-4 was more cautious, while ChatQA was more willing to make an educated guess.
I think that's a good way to put it.
What other examples were there?
Well, there was one about nature reserves. ChatQA correctly identified the reserve that covered more than 3,100 hectares, but GPT-4 got it wrong. It listed multiple reserves, including some that didn't actually meet the criteria.
So ChatQA was more precise with the numbers.
Right. And then the last case involved a question about the dates when someone destroyed or damaged enemy planes. GPT-4 correctly listed all the relevant dates, but ChatQA missed one.
So GPT-4 might have an advantage when it comes to those tasks that require real attention to detail.
It seems that way.
Okay, so basically, each model has its own pros and cons, and choosing the right one depends on what you need it to do.
Exactly. The right tool for the job.
Now, throughout the paper, the researchers use a lot of mathematical formulas to describe ChatQA's training and evaluation. I don't think we need to go into the specifics of each one, but can you give me a general idea of what they're for?
Sure. So those formulas basically provide a mathematical foundation for everything they did. Like, for example, equation 1 on page 6. That defines the contrastive loss function they use to train the dense retriever.
Okay.
And that loss function ensures that the retriever learns to tell the difference between relevant and irrelevant contexts.
So they're using math to make sure the model is learning correctly and making accurate predictions.
Exactly.
It's amazing how much complex math goes into these seemingly simple conversations.
It is. But the researchers have done a great job of explaining their methods clearly and concisely.
Well, this has been a fascinating deep dive into the world of ChatQA. It's incredible to see how much progress has been made in AI in such a short time. What are your overall thoughts on this research?
I think it's a really significant step forward, both for conversational AI and RAG. Their approach to training and evaluation is really innovative, and ChatQA's performance on the ChatRAG Bench is seriously impressive.
It's clear they put a lot of work into making ChatQA both accurate and reliable.
They did. And the fact that they've open sourced everything, the model weights, the training data, the benchmark, that's huge. It really shows their commitment to advancing the field.
Yeah, that's a great point. This research could benefit so many people, not just researchers, but also developers and companies who want to use conversational AI in their products and services.
Absolutely. And the potential applications are really exciting.
Well, I think we've covered a lot of ground in this first part of our deep dive. We'll continue our exploration in the next part. We'll go deeper into the specifics of the model's architecture and training process.
Sounds good. There's still so much more to uncover about this fascinating AI model.
Until then, keep those questions coming, and we'll see you on our next deep dive.
I'll see you then. So last time we were talking about ChatQA's two-stage training process. I think it would be helpful to actually visualize that.
Oh, visual. Yeah, that's a good idea.
Yeah.
Do they provide one in the paper?
They do. Figure 1 on page 3 illustrates it really well.
Okay.
It shows the two stages. The first one is labeled supervised fine-tuning, and it shows how they basically take a foundation LLM and turn it into the SFT model ChatQA through training.
Right. And they list the sources for the training data.
Yeah, you see datasets like SOTA, ELI5, Pelolan, DALI, Open Assistant, all below this arrow. That's the fuel for this first stage.
Right, and all those data sets we talked about last time, they cover all sorts of conversational styles and question-answering scenarios.
Exactly. And this stage gives ChatQA a really strong foundation in instruction following and, conversational fluency.
Yeah.
Then stage 2, the context-enhanced instruction tuning, that one gets even more interesting.
How so?
Well, you see them bringing in additional data sets, things like narrative QA, drop, CoreRef, ropes, squad, news QA, TAT QA, and conversational QA.
Okay, and all of those are specifically chosen to help ChatQA answer questions within a given context.
Right, so it can integrate those retrieved chunks of information that we were talking about last time.
Okay.
So this stage is really about honing ChatQA's contextual understanding and its ability to do that retrieval augmented generation.
Okay, so figure 1, it really captures the whole training process.
It does. Then there's figure 2 on page 6. That one visualizes how they handle retrieval for those multi-turn conversations.
Okay, I see that it mentions contrastive fine-tuning. What is that?
So contrastive fine-tuning, it's a way of training those dense retrievers.
Okay.
And the figure shows a query encoder and a context encoder.
Right. What do those do?
Those take the queries and the context and turn them into these numerical representations. Then the contrastive fine-tuning maximizes the similarity between the representations of pairs that are relevant, but minimizes the similarity between pairs that are not.
Oh, okay, so it's basically forcing the model to learn these meaningful representations that capture how queries and contexts relate to each other.
Exactly.
Okay, I also see that they mention multi-turn queries in the figure.
Right, so that means the retriever is actually trained to understand those queries in the flow of a conversation, even when a question refers back to something that was said earlier.
That's pretty cool. Okay, so figure 2 gives a good overview of their retrieval approach.
It does. Now, moving on to table 2 on page 9, this shows what they call the zero-shot results on the ChatRAG Bench.
Okay, there's a lot of information in this table. What am I looking at here?
So it's comparing different ChatQA models, including those based on Llama 2 and Llama 3, and it's comparing them to some other strong baselines like Llama 2 Chat, Llama 3 Instruct, and Command R+.
Okay.
And it also includes the OpenAI models, so GPT 3.5 Turbo 0613, GPT 4 0633, and GPT 4 Turbo 2024 0409.
Okay.
And it shows the average scores across all 10 of those ChatRAG Bench datasets.
Right.
And then it also gives you the individual score for each dataset, so you can see how they did on each specific task.
Okay, that makes sense. So what were the big takeaways?
The ChatQA 1.070B, the one based on Llama 2, that one actually outperformed both GPT 4 0613 and GPT 4 Turbo 2024 0409 on average.
Wow, okay. That's impressive.
It is, especially since they didn't use any synthetic data from those OpenAI GPT models.
Right, so a win for open source.
Yeah. And if you look at the individual dataset scores, ChatQA 1.0-70B did really well across the board. It was really consistent, showing how versatile it is.
Okay.
It was great on datasets like Quashu, CoQA, DoQA, ConfinQA.
Okay.
Those show its question answering capabilities in lots of different domains.
Right.
It had a bit more trouble on datasets like SecQA and HybridDial. Those involve more tabular reasoning, so those are areas for improvement.
Okay.
But overall, really good results.
Yeah.
And then if you look at the smaller Llama 3 ChatQA 1.58B model, that one actually got results that were similar to the GPT-4 models.
Oh, wow, okay.
So the Llama 3 architecture, it seems to be really efficient.
Yeah.
And then Llama 3 ChatQA 1.570B, the bigger one, that one actually beat both of the GPT-4 versions.
Okay, so setting a new state-of-the-art.
Exactly.
That's really exciting.
It is. It shows how much potential there is in open source conversational AI.
Right. Okay, so earlier we were talking about those ablation studies they did to see how different components affected performance.
Yeah, those are in table 3 on page 10.
Okay.
So the first row of the table, that's the ChatQA 1.070B model with all the components included. That's the baseline.
Okay, so everything else is compared to that.
Right. And then the other rows show what happens when you remove or change things. So like if you remove the stage 1 supervised fine-tuning, performance goes down on almost all the data sets.
Yeah, that was one of their key findings. It really showed how important that initial stage is for developing those core skills.
Right, the instruction following and conversational fluency.
Exactly.
And then removing the stage 2 context-enhanced instruction tuning, that also made accuracy go down a lot. So
Right.
Context is really important.
Makes sense.
And then the table also looks at the different types of data they used for training. If you remove the single-turn QA datasets from the second stage, the scores are generally lower.
Interesting. So those single-turn data sets, even though they seem simpler, they're still important for learning how to use context effectively.
Yeah, they contribute in their own way.
Okay.
But then removing the conversational QA data, that had an even bigger impact, especially on the data sets that had those text-based documents. So if you want good conversational question answering, you have to train on conversational data.
Makes sense.
And then they compared using human annotated data versus the synthetic data generated by GPT 3.5 Turbo.
Right, right.
And they found that both approaches gave similar results. So in some cases, you could use that high-quality synthetic data instead of having humans do all the annotation.
Oh, interesting. Okay, so it seems like they really thought about all the different pieces and how they fit together.
Oh, yeah, they were very thorough.
Okay, what about Table 5?
So Table 5 breaks down the results based on the types of data sets. So whether they're text only or if they include tables.
Okay.
And it also separates out the retrieval and non-retrieval data sets. So it gives you a more fine-grained view of what ChatQA is good at.
Okay, what did they find?
So ChatQA 1.070B, the one based on Llama 2, that one did better on the datasets with text-only documents compared to the ones with tables. So it seems like it's better at understanding and reasoning with text.
Okay, so ChatQA is a good reader.
Yeah, you could say that. But then the Llama 3 ChatQA 1.5 models, those did better on the datasets with tables, especially the 70B version. So maybe the Llama 3 architecture is better for tasks with tabular data.
Interesting. So each model has its own strengths.
Right. And then Table 5 also shows that ChatQA 1.070B did about as well as GPT-4 on both retrieval and non-retrieval data sets. So its retrieval capabilities seem to be right up there with other state-of-the-art models.
That's great. So good at conversation. A&D, good at retrieval.
Yep. And then Table 6 looks at what happens when you incorporate those retrieved chunks during training.
Okay.
They compare ChatQA 1.070B, trained with the top 5 retrieved chunks as context, versus training it with the whole document as context.
Okay.
And the table shows the average scores on ChatRAG Bench, and then also the scores for retrieval and non-retrieval data sets separately, so you can really see the impact.
Okay. And what did they find?
So using those retrieved chunks during training, it helped on the retrieval data sets, like we saw before. But it hurt a little bit on the non-retrieval data sets, so there's a trade-off there.
Yeah, we were talking about that earlier.
And the researchers say that using the retrieved chunks makes the training more like the inference stage, where you need retrieval, but it can also make the training less stable, which might explain why it doesn't do as well on the non-retrieval data sets.
Right. So there are pros and cons to each approach.
There are.
Okay, what about Table 7?
That one is about the ablation studies they did during inference. So, like, after the model is trained, how different factors affect performance.
Okay.
And they specifically looked at the data sets that require retrieval. So DocDoDial, QACI, QRECC, TopioQA, and NSCIT.
Okay.
And the first few rows of the table, those look at how many retrieved contexts they used as input. They compared using the top 3, the top 5, and the top 10.
Okay.
And what they found was that using more context didn't always lead to better results. Using the top 5 seemed to be the sweet spot.
Okay, interesting. So more information isn't always better.
Right. You need enough, but too much can be overwhelming.
Makes sense.
And then they looked at different ways of ordering those contexts. So they compared sequential ordering, reverse ordering, swing ordering, and random ordering.
Right. Swing ordering was that thing to try to avoid information getting lost in the middle.
Exactly. And they found that sequential ordering, where you arrange the context from most to least relevant, that did about the same as reverse and swing ordering, but random ordering did a bit worse. So it seems like as long as there's some logical structure to the order, ChatQA does fine. And then the last row of the table, that compares using their fine-tuned retriever versus using the original Dragon retriever.
Okay.
And like we saw before, the fine-tuned one does better. So that improved retrieval leads to better question answering.
Right. The quality of the retriever matters.
It does. So those ablation studies during inference, they show that you have to think about things like how many contexts you use, how you order them, and how good your retriever is. All of those things can affect performance.
Makes sense. Okay, so Table 8, we talked about that one before.
Yeah.
It's about how well ChatQA does on those unanswerable questions.
Right. So that table shows the results on the QACI and DoQA datasets. Those are the ones that include those unanswerable cases.
Okay.
And it compares different ChatQA models and some baselines and the OpenAI models.
Right.
And it shows the average accuracy across both datasets, and then also the accuracy for unanswerable and answerable cases separately. And one of the big takeaways is that using human annotated data really really helped ChatQA on those unanswerable cases. It shows that having good training data is crucial for that.
Yeah, we were talking about that earlier.
And ChatQA 1.070b actually did much better than GPT 3.5 Turbo on average, though it was still behind GPT-4 0613.
Okay.
But what's interesting is that adding more unanswerable examples during training didn't always lead to higher accuracy.
Oh, really?
Yeah, it seems like using around 1,500 of them is a good balance. Enough to teach the model, but not so many that it just starts saying, I don't know all the time.
Right. You don't want it to give up too easily.
Exactly. So a well-curated data set is really important.
Okay. What about Table 10?
So that one has those case studies, comparing ChatQA 1.070b with GPT-4 0613 on real-world examples.
Right, we talked about those before. Can you remind me of some of the examples?
Sure. So one example was about VA appeals processes. Both models got the right answer from the text.
Okay.
But GPT-4's answer was more complete. It had more details about the conditions for using the new process.
So GPT-4 was more thorough.
Yeah. And then there was one about the age of a child mentioned in a text. GPT-4 correctly said that the text didn't give the age, but ChatQA assumed the child was a baby, just based on the context.
So ChatQA is more willing to make inferences.
It seems that way. And then there was one about nature reserves. ChatQA correctly identified the one that was over 3,100 hectares, but GPT-4 got it wrong. It listed a bunch of reserves, some of which didn't even meet the criteria. So ChatQA seems to be better at handling those numerical details.
Okay.
And then the last one was about dates when someone had destroyed or damaged enemy planes. GPT-4 listed all the dates correctly, but ChatQA missed one. So maybe GPT-4 is better at those tasks that require real attention to detail.
Yeah, those tiny details can be important.
They can. So those case studies really show the strengths and weaknesses of each model.
Yeah, and they highlight how important it is to choose the right model for the specific task.
Exactly.
Now, throughout the paper, they use a lot of mathematical formulas to describe how they trained and evaluated ChatQA. We don't need to go into the details of each one, but can you give me a general idea of what they're for?
Sure. So those formulas basically provide the math behind everything they did.
Yeah.
Like, for example, equation 1 on page 6.
Okay.
That defines the contrastive loss function they use to train the dense retriever.
Okay.
And that makes sure the retriever learns to tell the difference between contexts that are relevant and those that aren't.
Right. So the math makes sure the model is learning the right things.
Exactly. And even though the math can be complex, the researchers do a good job of explaining everything in a way that's easy to understand.
Okay, good. So we've looked at all these figures and tables and even some math.
Right.
What are the big takeaways from the ChatQA research?
So I think one of the biggest is that they've come up with a new way to do conversational question answering and retrieval augmented generation. Their two-stage training process, it really seems to work.
Okay.
And using that fine-tuned single-turn query retriever, that's a really efficient and effective approach.
Right.
And ChatQA 1.070b, the one based on Llama 2, that one gets state-of-the-art results on ChatRAG Bench.
Right. It even beats GPT-4.
It does. And then the Llama 3 ChatQA 1.5 models, those are even better. They outperform GPT-4 across the board.
Okay.
And the research really highlights how important it is to have a good data set. You need both single-turn and conversational QA data. And they also showed that you can use synthetic data generated by GPT 3.5 Turbo as an alternative to having humans do all the annotation.
Okay, that's good to know.
And they've made a lot of progress in handling those unanswerable questions, so they're reducing those hallucinations.
Yeah, by incorporating those unanswerable examples during training.
Right. And then those case studies, they show that ChatQA can actually handle real-world problems.
Yeah, it's not just theoretical.
Exactly. So overall, I think this research is a big step forward for conversational AI. It sets a new standard.
It does. It's really impressive.
So we've covered a lot of ground with ChatQA, but I wanted to touch on one more thing.
Okay, what's that?
The fact that the researchers open-sourced everything, I think that's really huge.
You mean the model weights, the training data, the benchmark?
Yeah, all of it. It means other researchers and developers can build on their work. It's a really big contribution to the field.
That's great.
It shows a real commitment to collaboration and transparency.
Yeah.
So I think that's worth highlighting. And then going back to evaluating those unanswerable cases, making sure the AI doesn't hallucinate.
Yeah, that's important.
It is. Section 6.5 of the paper focuses on that specifically.
Okay.
And they looked at the ChatQA and DoQA datasets because those include cases where there isn't a right answer in the context.
Right.
And they didn't just use automatic metrics. They actually had human evaluators to see how well the models could recognize and handle those situations.
Right.
Table 8 on page 14 shows those results. And one of the things that really stands out is the impact of using human annotated data, especially on those unanswerable cases.
Right, that high-quality training data, it really makes a difference.
It does. And even though ChatQA 1.0-70b doesn't quite match GPT-4 0613 on that metric, it's still a big improvement over what we've seen before.
Right, so they're making progress on that problem of AI hallucination.
Yeah, definitely. And their approach to incorporating those unanswerable examples during training, I think that's really interesting. They experimented with different numbers, and they found that more isn't always better.
Oh, really?
Yeah. It seems like using around 1,500 unanswerable samples, that's a good balance. Enough to teach the model, but not so many that it just gives up too easily.
Right, so it's a balancing act.
It is.
Okay, I like that they included those real-world examples, too, those case studies.
Yeah, those are in Table 10 and Appendix G. They compare ChatQA 1.070b with GPT-4.
Yeah, we talked about those earlier.
It's really helpful to see those concrete examples.
Yeah, and to see how those different models handle things, sometimes in very different ways.
Exactly.
Yeah.
Like with that example about the VA appeals process, both models found the right answer, but GPT-4's explanation was more complete. It was more thorough.
Right.
So it just shows that there are these subtle differences in how the models approach things, and that's important to keep in mind, depending on what you want to use them for.
Yeah, different models for different tasks.
Exactly. And then that example with the child's age, GPT-4 correctly said that the text didn't actually say the age. Right. But ChatQA made an assumption based on the context.
So GPT-4 is more cautious, ChatQA is more willing to fill in the blanks.
I guess you could say that. So yeah, those case studies, I think they're really valuable.
Yeah, they are. Okay, so I think we've explored just about every nook and cranny of ChatQA at this point.
I think so. We've covered the training process, the evaluation, the results.
The data sets, the figures, the tables, even the math.
For the math.
So as we wrap up this deep dive, what are your final thoughts on this research? What stands out to you?
Well, I think this research is a really significant contribution to conversational AI. And to RAG, too. The way they approach things, the two-stage training process, using that single-turn query retriever, it's really innovative. And the results they got, those are impressive, especially for an open-source model.
Yeah, and the fact that they've open-sourced everything, I think that's huge.
It is. It means others can build on their work. They can try out different things. They can improve the models even further. It's really pushing the field forward.
Right, that open collaboration, it's really important.
It is. So I'm really excited about this research. I think it has a lot of potential, and I'm eager to see what other researchers do with it.
Yeah, me too. Well, thank you for joining me on this deep dive into ChatQA. It's been a fascinating journey.
It has. Thank you for having me.
And to everyone listening, we encourage you to check out the research paper for yourselves. It's available online, and you can also find the data sets and the code they used.
Yeah, dive in and explore.
And as always, keep those questions coming. We'll see you on our next deep dive. Until then, happy exploring.